November 11th, 1944, 11:47 a.m. Vladivostok Air Base, Soviet Far East. The ground crew sees it first, silver speck growing larger against the gray Pacific sky, wings wobbling like a wounded bird searching for somewhere to die. It's massive, bigger than anything in the Soviet inventory. The distinctive shape is unmistakable, even from 5 kilometers out. For engines, high tail, that graceful fuselage that American engineers spent years perfecting. It's a B-29 Superfortress. It's not supposed to be here. Senior Lieutenant Mikhail Volkov drops his cigarette. Round him, mechanics freeze mid-task, wrenches hanging loose in oil-stained hands. The bomber's approach is all wrong, too steep, too fast. Landing gear already down but one engine trailing smoke like a funeral shroud. The piercing whine of stressed metal cuts through the autumn air as the American pilot fights physics itself, trying to coax 35 tons of aluminum and secrets onto a runway that was never meant to receive it. The wheels kiss concrete with a screech that makes every man wince. Sparks fly from the starboard landing gear. The bomber lurches, fishtails, and somehow impossibly straightens out. It rolls past the stunned Soviet ground crew, slowing, finally shuddering to a stop 300 meters down the tarmac. Silence. Then the base erupts. Volkov is already running, his boots pounding asphalt, his heart hammering against his ribs. Behind him, officers are shouting contradictory orders. Armed guards scramble from their posts. Air raid sirens, activated by reflex more than reason, begin their mournful wail. But Volkov's eyes are locked on the bomber's forward hatch as it cranks open. One by one, American airmen emerge, 11 of them, exhausted, faces streaked with hydraulic fluid and fierce sweat. Their flight suits are torn in places, darkened with what might be blood or might be fuel. The pilot, a captain whose name Volkov will learn, is Howard Yarl, climbs down last. And when his boots hit Soviet soil, his legs nearly buckle. Mechanical failure, Yarl will tell the NKVD interrogators 6 hours later, his Russian translator stumbling over aviation terminology. We were returning from Manchuria, loud hitting Japanese steel production. Lost an engine over the Sea of Japan. Couldn't make it back to our base. But it's what Yarl doesn't say that matters more. Because the Soviet Union isn't at war with Japan, not officially. Stalin has a non-aggression pact with Tokyo, a delicate diplomatic dance that keeps Russia's eastern flank secure while the real war the apocalyptic struggle against. Nazi Germany grinds through its 4th year of meat and mud and burning cities. An American bomber attacking Japanese targets from Soviet-adjacent airspace is a provocation. A diplomatic crisis wrapped in aviation fuel, and wrapped again in raw military necessity. And it's sitting right there on the tarmac. Within 2 hours, the bomber is surrounded by canvas tarps and armed guards. Within 4, it's being towed to a remote hangar on the far side of the airfield, away from prying eyes, though whose eyes, exactly, the Soviets are worried about isn't clear. The Americans? The Japanese? Their own people? The crew is treated well-fed, given beds, even vodka, but they're not free. They're interned, a word that sounds gentler than imprisoned, but amounts to the same chain around your ankle. They'll spend the next year in comfortable detention, waiting for the diplomatic wheels to turn slowly enough to send them home. March 3rd, 1945. Factory number 22, Moscow. 6:15 a.m. The first B-29 arrives on 42 flatbed railcars, disassembled like a mechanical cadaver, dissected for study. Andrei Tupolev stands in the freezing pre-dawn darkness, watching workers unload sections of fuselage, wing panels wrapped in canvas, engines crated in wooden boxes stamped with Cyrillic warnings. Fragile, strategic importance, do not drop or you will be shot. That last part isn't printed on the crates, but everyone understands it anyway. Tupolev is 56 years old, his face carved into angles by wind tunnel testing and gulag rations. He's designed some of the Soviet Union's best aircraft, the Ant-25 that flew over the North Pole, the TB-3 heavy bomber that once represented the cutting edge of Soviet air power. But standing here, watching American engineering emerge piece by piece from those railcars, he feels like a medieval blacksmith being asked to reproduce a rifle. The second bomber arrives 3 days later. It's the third, a week after that. When all 3 are finally reassembled inside the cavernous factory hall, Tupolev walks the length of the first aircraft with his hands clasped behind his back, saying nothing. His chief engineers follow in a silent procession. Bazinkov, Kerber, Selikovman, whose combined expertise represents the pinnacle of Soviet aviation knowledge. They stop beneath the B-29's nose, Look up at the plexiglass bombardier station. The curves and compound angles that somehow manage to be both aerodynamic and beautiful. Well, Tupolev finally says silence. Then Kerber, the structure specialist, speaks quietly. The skin thickness varies across the fuselage. Different gauges for different stress zones. The Americans must have stress maps we can only guess at. Bazinkov, chief of engines, adds, the Wright R-3350 SU's technologies we've seen in captured German documents, but the manufacturing precision. He trails off, shaking his head. Tupolev already knows. He spent the last week studying technical reports, measurements, metallurgical analyses. The B-29 isn't just advanced. It's advanced in ways that expose every gap in Soviet industrial capability. The aluminum alloys are different, stronger, lighter, with properties that Soviet metallurgy cannot yet replicate. The hydraulic systems operate at pressures that would blow Soviet seals to pieces. The electrical wiring uses insulation materials that don't exist in Russian factories. Even the rivets, those tiny fasteners holding the whole magnificent beast together, are heat-treated too. Specifications that Soviet manufacturers have never attempted, and Stalin wants an exact copy. It's not an inspired by version, not a Soviet interpretation. An exact copy. We'll need to photograph everything, Tupolev announces. Every panel, every bracket, every wire run. There are 30,000 parts. We photograph 30,000 parts. 47,000, Kerber corrects softly. Tupolev doesn't blink. Then we photograph 47,000 parts. What follows is perhaps the most meticulous act of industrial archaeology in history. Teams of engineers swarm over the three B-29s like surgeons performing an autopsy on something they're simultaneously trying to resurrect. Every component is removed, measured with calipers and micrometers, weighed on precision scales, photographed from multiple angles, then catalogued with Byzantine thoroughness. The aluminum skin panels, some as large as a dining table, are laid out on factory floors and traced onto paper templates. Wing spars are sectioned and analyzed for internal structure. Hydraulic lines are pressurized with colored fluids to map their routing through the fuselage. The engines alone consumed 3 months. The Wright R-3350 duplex cyclone is a masterpiece of American engineering. 18 cylinders arranged in 2 rows. Each cylinder fed by a complex fuel injection system that adjusts mixture based on altitude, temperature, and throttle position. The Soviets have nothing comparable. Their best radial engine, the Ash-73, is simpler, less powerful, and still prone to overheating. Bazinkov's team disassembles the first R-3350 down to individual components. They find forged crankshafts with internal oil passages drilled through solid steel, a manufacturing feat Soviet factories cannot reproduce. They find cylinder heads with cooling fin geometries optimized through wind tunnel testing the Soviets never conducted. They find fuel injection nozzles machined to tolerances that require equipment the Soviet Union doesn't possess. We can't make this, Bazinkov tells Tupolev one night, his voice hollow with exhaustion. Not exactly. We'll have to modify, simplify. No. Tupolev's response is immediate, absolute. Stalin said exact. We make it exact. Then we'll need new machinery, new tools. We'll need to upgrade entire factories. Then we upgrade entire factories. But it's the pressurization system that nearly breaks them. The B-29 was the first operational bomber with a fully pressurized crew, compartment allowing the men inside to fly at 30,000 feet without oxygen masks, in shirt-sleeve comfort, while outside the temperature drops to 40 below zero. It's a system of airlocks, pressure seals, bulkheads rated for differential pressures that would crush a man's chest, and air pumps driven by engine bleed air. Soviet engineers have experimented with pressurization. They've built test chambers. They've studied German research, but they've never made it work reliably at scale. The seals are the nightmare. American rubber compounds maintain elasticity at extreme temperatures. Soviet rubber becomes brittle at altitude, cracks under pressure, cycling, fails catastrophically when stressed. The first test pressurization of a Soviet-built fuselage section results in a seal. Failure so violent it sounds like a rifle shot through the factory floor. Kerber spends 6 weeks just trying to reverse engineer the rubber formulation. He collects seal samples from all 3 B-29s, cuts them into slivers, subjects them to chemical analysis, heat tests, cold tests, tensile tests. He fills notebooks with molecular diagrams and temperature curves. Finally, he develops a compound that comes close. Not identical, the Americans are using some proprietary additive he cannot identify, but close enough that it might work. Meanwhile, other teams grapple with other impossibilities. The remote gun turrets use Sperry analog computers, electromechanical marvels of gears and servos that calculate lead angles and deflection automatically. Soviet engineers stare at the mechanism like archaeologists confronting an alien artifact. They understand what it does. Understanding how it does, it requires weeks of testing, observing, mapping electrical circuits, node by painstaking node. The radar systems are encrypted mysteries. The navigation instruments use manufacturing techniques the Soviets will need 2 more years to master. Even the paint, that distinctive silver finished, turns out to be a specialized aluminum lacquer that reduces drag and reflects heat. Every answer creates 3 new questions. And through it all, Tupolev moves among his teams like a prophet in a mechanical wilderness, offering encouragement, demanding miracles, occasionally erupting in volcanic fury when someone suggests that exact replication might be impossible. Because impossible is not a word that exists in Stalin's vocabulary, and men who use it tend to disappear. 6 months into the project, Tupolev compiles a report. It's 47 pages long, dense with technical specifications and metallurgical data. The conclusion is 3 sentences. Complete replication of the B-29 will require restructuring significant portions of Soviet aviation industry. New materials must be developed. New manufacturing processes must be invented. Its estimated timeline, 3 years minimum. He hand-delivers it to the Kremlin. Waits in an anteroom while Stalin reads. The 45 minutes he spends sitting in that chair, watching the clock tick, are among the longest of his life. Finally, an aide opens the door. Comrade Stalin says 3 years is acceptable, the aide announces. He also says that if you fail, Siberia is colder than any altitude your precious bomber flies at. Tupolev nods. Stands, walks out into the Moscow twilight with his hands trembling just slightly in his coat pockets. Back at factory number 22, his engineers are waiting for the verdict. We have 3 years, Tupolev tells them. Someone laughs, a brittle, slightly hysterical sound quickly swallowed. Because they all know what 3 years means. 3 years of 18-hour days. 3 years of impossible deadlines and materials shortages, and the constant awareness that failure means not just professional disgrace, but potential death. 3 years to transform 3 wrecked American bombers into the foundation of Soviet strategic air power. The first prototype component, a single aluminum rib from the wing's inner section, is manufactured 6 weeks later. It's tested for strength. Weighed compared microscopically to the original. It's 0.3 millimeters too thick. They start over. August 17th, 1945, Metallurgical Laboratory, Factory number 22, 2:33 a.m. Dmitry Markov hasn't slept in 31 hours. His eyes are bloodshot, his hands stained with chemical reagents. And he's staring at a piece of aluminum the size of a postage stamp, like it holds the secrets of the universe. Yes, it does. The sample came from the B-29's bomb bay door panel that needs to be strong enough to support its own weight. It's light enough not to compromise payload capacity and resistant to thermal stress from rapid altitude changes. The Americans achieved this with an alloy designated Tu-4 Saint. Markov's job is to figure out exactly what Tu-4 Saint is made of and then convince Soviet foundries to produce it. He's been at it for 4 months. The spectrographic analysis revealed the basic composition easily enough. Aluminum, copper, magnesium, manganese. But it's the ratios that matter, the precise percentages that give the alloy its properties. Too much copper and it becomes brittle. Too little magnesium and it loses strength. The heat treatment process matters. To temperature, duration, cooling rate, change any variable by a fraction and you get an entirely different material. Markov runs his 43rd test sample through the tensile strength machine. The metal stretches under load, stretches further, then snap. The failure point is wrong. Again, his alloy is fracturing at 18,000 pounds per square inch when the American sample holds until 22,000. He wants to scream. Instead, he adjusts his notes and starts preparing test sample 44. Across the factory complex, 100 similar battles are being fought. In the propeller shop, engineers are trying to reproduce the Hamilton standard constant speed propellers, massive 4-bladed units that automatically adjust pitch based on engine RPM and airspeed. The mechanism is a miracle of hydraulic engineering and mechanical feedback systems. Soviet propellers use simpler 2-position mechanisms. Building something this sophisticated requires developing entirely new hydraulic governors, new blade pitch actuators, new control systems. The first test propeller destroys itself on the test stand, throwing a blade through the reinforced concrete wall like a javelin. The technician operating the controls dives for cover half a second before 8 feet of spinning metal cuts through the space where his head had been. No one is injured. But the message is clear. Getting this wrong has consequences measured in shrapnel velocity. In the electrical systems laboratory, a young engineer named Svetlana Petrova is mapping the B-29's wiring harness. Literally thousands of individual wires running through the fuselage, wings and empennage, each one color-coded. Each one routed through specific channels. Each one terminated with connectors that Soviet industry doesn't manufacture. She's developed a system. Photograph every wire bundle. Trace every connection. Create massive diagrams that sprawl across entire walls. Her workspace looks like a conspiracy theorist's fever dream papers connected by colored strings. Circuit diagrams annotated in 3 different colors of ink. Coffee-stained notes documenting the function of every relay, every switch, every fuse. The Americans used a standardized wire gauge system that doesn't map cleanly to Soviet standards. Petrova is creating conversion tables, cross-referencing American wire gauge to Soviet classifications, making thousands of tiny decisions that collectively determine whether the electrical system will work or become a fire hazard at altitude. She hasn't been home in 6 days. But perhaps nowhere is the challenge more acute than in the pressurization team's workshop. Yuri Selikov Tupolev's chief systems engineer stands inside a cylindrical test chamber watching pressure gauges climb. The chamber is a mock-up of the B-29's forward fuselage section. It's built to the exact specifications, sealed with the rubber compounds that Kerber's team finally got right on the 38th iteration. The needles climb. 3 pounds per square inch differential. 4.5. At 5.8 psi, they hear it a whistle. High-pitched, getting louder. Leak, someone shouts. Selikov signals to abort. The chamber depressurizes with a sigh like the world's largest balloon deflating. When they open the hatch, they find the leak source. A rivet hole where the seal wasn't perfectly flush. Gap measured in fractions of a millimeter. Invisible to the naked eye. Fatal at altitude. They mark the location. Document it. Add it to the growing encyclopedia of lessons learned through failure. Because here's what the history books often miss. Reverse engineering isn't just copying. It's archaeology and detective work and manufacturing innovation, all compressed into an impossible timeline. The Americans didn't hand over blueprints. They didn't provide material specifications or assembly manuals. Everything the Soviets learned, they learned by breaking things, testing things, failing and trying again. Every rivet becomes a research project. Every weld a case study. And Stalin's deadline is counting down. By December 1945, Factory Number 22 has become a city unto itself. 20,000 workers on rotating shifts. Workshops operating 24 hours a day. The night shift illuminated by harsh electric lights that turn men's faces into skull masks of exhaustion. The factory floor is a symphony of industrial violence, pneumatic hammers, metal saws, the thunder of hydraulic presses stamping aluminum sheets into compound curves. Tupolev walks through it all like a ghost, his footsteps echoing on concrete floors, his eyes taking in everything. He stops at workstations, asks questions, occasionally corrects a technique, or suggests an approach. The workers revere him and fear him in equal measure. He's their shield against Moscow's demands and their harshest critic. One afternoon, he finds a young toolmaker hand-filing a bracket to match the American original. The work is exquisite microscopic adjustments, constant measurement checks, the kind of craftsmanship that machines cannot replicate. "How long have you been working on this?" Tupolev asks. 3 days, comrade designer. "How many do we need?" 412. Tupolev does the math instantly. 3 days times 412 brackets equals nearly 3.5 years. Just for this one component. "We need to manufacture tooling," he says quietly. "Die stamps. We can't hand-file 400 brackets. The tolerances." "I know." Tupolev's voice is gentle, but firm. "We'll design fixtures that hold the tolerances. We'll make the machines do what your hands do. Because your hands are brilliant, but they're also only 2 hands. This is the other revolution happening inside. Factory Number 22 not just copying the B-29, but transforming Soviet manufacturing to make copying possible. New machine tools are designed and built. Hydraulic presses are modified to handle larger aluminum sheets. Heat treatment furnaces are calibrated to maintain temperatures within a single degree. Quality control protocols are established that would make American factory managers nod in recognition. The Soviet Union is industrializing its aviation industry a second time, dragging it from 1930s standards into the 1940s through sheer force of necessity. But some problems resist even the most determined solutions. The engines remain the nightmare that haunts Bazenkov's sleep. The R-3350's complexity is staggering, parts within parts within parts, each one dependent on the others. The fuel injection system alone has over 300 discrete components. The supercharger uses impeller blades with aerodynamic profiles that Soviet foundries cannot cast accurately. In June 1946, the first Soviet-built test engine, designated the Ash-73TK, is mounted on a test stand. Engineers gather like priests at an altar as fuel lines are connected, ignition systems checked. Bazenkov himself turns the starter. The engine coughs, catches, roars to life, with a sound like controlled fury. For 43 seconds, it runs perfectly. Power output matches predictions. Vibration levels are acceptable. Temperature gauges read normal. Then a connecting rod fractures. Failure cascades piston through cylinder wall, fragments through the crankcase, oil spraying across the test stand in a black fountain. The engine shreds itself in under 2 seconds, a catastrophic disintegration of metal and engineering ambition. When the smoke clears, Bazenkov stands motionless, staring at the wreckage. The metallurgy, he says finally. The connecting rod material. It's not strong enough. They return to the foundries. Adjust the alloy composition. Run new tests. Try again. The second engine lasts 71 seconds before a valve spring fails. The third makes it to 4 minutes before the supercharger seizes. Each failure is analyzed, documented, learned from. The problems are being solved. Slowly, painfully, expensively, but they're being solved. By the time autumn 1946 arrives, factory number 22 has produced what Tupolev calls pre-production prototypes of nearly every major system. Not quite production ready, not quite reliable enough for flight. But close. Getting closer. Pressure's enormous. Stalin receives weekly reports. Sometimes he sends comments, observations, or pointed questions that make Tupolev's hands shake when he reads them. Other times, NKVD officers appear unannounced, touring the facilities with notebooks and cold eyes, asking why this component isn't finished, why that test failed. Engineers start sleeping at the factory, not because they're forced to, though that's certainly part of it, but because going home means lying awake thinking about all the work waiting for them. It's better to stay, to keep pushing, to steal a few hours of sleep on a cot between shifts. Marriages strain. Health deteriorates. Tupolev himself develops a chronic cough that he ignores until it's impossible to ignore, then treats with vodka and raw stubbornness. But the bomber is coming together. Piece by impossible piece. May 19th, 1947, Flight Test Center, Zhukovsky Airfield. 5:47 a.m. The bomber sits on the tarmac like a silver promise, its 4 engines silent, its propellers still. From a distance, it's identical to the American B-29s that inspired it. Same graceful fuselage, same high tail, same compound curves that took Soviet workers to years and 3 months to reproduce. But it's not a B-29. It's the Tupolev Tu-4, the first Soviet strategic bomber, capable of reaching targets thousands of kilometers away, the first Soviet aircraft with pressurized crew compartments and remote-controlled guns, the first tangible proof that Stalin's insane gamble copy 3 wrecked American bombers exactly might actually succeed. Andrei Tupolev stands 50 meters from the aircraft, close enough to see the morning sun glint off its aluminum skin, far enough that if something goes catastrophically wrong during engine start, he might survive. Behind him, a crowd has gathered: engineers, factory workers, military officers, NKVD representatives, who have come to witness either triumph or disaster. No one is certain which it will be. The test pilot is Mark Galea, veteran with over 15 years of experience, and a man who's flown everything from nimble fighters to lumbering transports. He's studied the American flight manuals that the NKVD somehow acquired. He's practiced on simulators built from salvaged B-29 cockpit sections. He's memorized every gauge, every control, every emergency procedure. But this is different. This is flying a bomber that was assembled from photographs and measurements and educated guesses. This is trusting that 47,000 components, each one reverse engineered. Each one manufactured by workers who'd never seen the American original will work together at altitude, under stress, when lives depend on it. Galea climbs aboard at 6:02 a.m. His flight engineer follows. Then the navigator, the radio operator, the bombardier. The crew is small for this initial test. No gunners, no full combat load. It's just enough men to fly the aircraft and enough instrumentation to record every vibration, every temperature fluctuation, every pressure reading. Inside the cockpit, Galay runs through the pre-flight checklist. His hands move across switches and levers with practiced precision, but his heart is hammering. Through the windscreen, he can see Tupolev standing on the tarmac, absolutely motionless. The old man's entire career, possibly his life, depends on the next hour. No pressure. Starting number 1, Galay announces. The starter engages with a whine. Propeller begins to turn slowly at first, then faster. The engine coughs again, then catches with a roar that ripples across the airfield. Blue smoke pours from the exhaust, then clears. The propeller becomes a blur. Number 1 running normally, the flight engineer reports. They start engines 2, 3, and 4. Each one fires up, settles into a steady rumble. Galay checks oil pressure, cylinder head temperature, manifold pressure. Everything reads normal. Everything reads like it might actually work. Tower, this is 01 requesting taxi clearance, Galay says into his radio. 01, you are cleared to taxi. The Tu-4 begins to move. Slowly at first, Galay is gentle with the brakes, testing their response, feeling how the massive bomber handles. 47 tons of aluminum and steel and Soviet determination rolling toward the runway threshold. On the tarmac, Tupolev watches. His face reveals nothing. But his chief engineer, Kerber, standing beside him, notices the old man's hands are clenched into fists, so tight the knuckles have gone white. The bomber reaches the runway. Galay aligns it with the center line, locks the tail wheel, runs through the final checks. Control surfaces, free and correct. Trim, set for takeoff. Engines, all for showing full power available. Tower 01, ready for departure, a pause. Then, 01, you are cleared for takeoff. Wind calm, good luck, good luck. As if luck has anything to do with it. As if 2 years and 3 months of engineering obsession, metallurgical innovation, and manufacturing revolution can be reduced to luck. Galay pushes the throttles forward. The engine's roar builds to something beyond sound, a physical force that vibrates through the airframe, through the crew, through the ground itself. The Tu-4 begins to roll, slowly at first, then faster. The runway markings blur beneath the nose. 50 kilometers per hour, 70, 90. At 140 kilometers per hour, Galay eases back on the yoke. The nose rises. The main gear stays planted for a moment to moments, then the bomber lifts free of the earth with a grace that seems impossible for something so large. They're flying. On the ground, someone starts applauding. Then everyone is applauding, cheering. A wave of relief and pride and sheer disbelief washing over the crowd. Men are embracing, laughing, some even crying. 2 years of 18-hour days of failed tests and impossible deadlines. Of constant fear that Stalin's patience would run out, all of it vindicated in that single moment when the wheels left the runway. Only Tupolev remains still, watching the bomber climb, watching it bank slightly to the left, watching the gear retract cleanly into the nestles. His expression hasn't changed, won't change until the bomber lands safely, until every system has been tested, until success is measured in data, not emotion. Altitude 300 meters, Galay reports over the radio. All engines running smoothly. Pressurization system engaging. This is the moment. Pressurization system. That nightmare of seals and bulkheads and pressure differentials that nearly broke them. If it fails now, if a seal ruptures or a bulkhead cracks, the test flight ends immediately. Inside the cockpit, Galay watches the cabin pressure gauge. The needle begins to climb. 0.2 atmospheres differential. 0.3, 0.4, no leaks, no whistles. No sudden depressurization that would leave the crew gasping for oxygen. Pressurization holding, the flight engineer announces, and Galay can hear the smile in his voice. They climb to 3,000 meters. The engines are running beautifully. It's rated horsepower. Temperature is normal. Fuel consumption matching predictions. Galay tests the control surfaces. Ailerons, elevators, rudder. Everything responds crisply, predictably. The bomber handles like a dream. At 5,000 meters, they level off. Galay runs through a series of maneuvers, gentle banks, climbs, descents. The Tu-4 responds to each input with the stability of a bomber designed by people who understood aerodynamics intimately. Of course, those people were American, but the Soviets have learned their lessons well. Let's test the turrets, Galay says. The remote gun turrets, those electromechanical marvels that cause so much grief, rotate smoothly through their arcs. The gunners on the ground monitoring through remote stations report perfect tracking, perfect response. The Sperry-inspired analog computers are calculating lead angles without error. 30 minutes into the flight, they've tested every major system. Everything works. Not perfectly. There are minor vibrations that need investigation. A hydraulic pressure reading that's slightly low. Some electrical interference on one radio frequency, but nothing serious. Nothing that threatens the aircraft or the mission. 01 Tower requests you return for landing. The radio crackles. Galay banks the Tu-4 back toward the airfield. In the distance, he can see the crowd on the tarmac, grown larger now as word spread through the facility. Everyone wants to see the landing. Everyone wants to witness history complete itself. The approach is textbook. Galay bleeds off altitude, extends the landing gear, 3 solid thunks, as the gear locks down, lowers flaps and stages. The bomber settles onto its approach path like it's done this 1,000 times. The runway grows larger in the windscreen. Larger. The bomber crosses the threshold at exactly the right height, the right speed. Galay pulls power, flares, and the main gear kisses the concrete with barely a squeak. They're down. The propellers reverse thrust, helping slow the massive bomber. When they finally roll to a stop and shut down the engines, the silence is almost shocking after an hour of constant noise. Galay sits in the cockpit for a moment, hands resting on the yoke, letting the magnitude sink in. They did it. Against impossible odds, with inadequate resources, under crushing pressure, they built a copy of America's most advanced bomber, and it flies. When he climbs down from the aircraft, Tupolev is waiting. The old designer's face is still unreadable, but when he shakes Galay's hand, his grip is firm. His eyes bright with something that might be tears, or might be exhaustion, or might be both. Well, Tupolev asks. It flies, Galay says simply. It flies like they promised it would. Tupolev nods. Once. Then he turns to face the crowd of engineers and workers and officers who've gathered around the bomber. This is the first, he announces, his voice carrying across the tarmac. We will build more, better ones. We'll make improvements the Americans never thought of. We'll turn this into a Soviet bomber, not an American copy. It's vintage Tupolev acknowledging success while immediately pushing for the next challenge. But standing there in the morning sun, watching workers touch the bomber's skin with something like reverence. Even he allows himself a moment of satisfaction. They've done the impossible. But the impossible, it turns out, was just the beginning. Because Stalin doesn't want one bomber. He wants hundreds. He wants a fleet that can reach American cities, that can carry the Soviet Union's nascent atomic bomb program, that can project power across oceans and continents. He wants an air force, built on reverse-engineered American technology, and he wants it now. The first flight of the Tu-4 proves the concept works. What comes next? The production nightmare. The quality control battles. The race to train crews and establish doctrine will prove whether it can be sustained. But standing there on the tarmac, watching sunlight play across aluminum skin that took 27 months to produce, Tupolev allows himself to believe it's possible. After all, they've already accomplished the impossible once. October 8, 1947. Aircraft Factory Number 18, Kubyshev, 11:23 p.m. Foreman Pavel Sokolov watches the night shift struggle with fuselage section 17, and he knows they're going to miss quota again. It's the 3rd week in a row. The 3rd week that Moscow will receive reports of delays, of production shortfalls, of promises broken. The 3rd week Sokolov will go home wondering if the NKVD is coming for him. The problem isn't the workers. They're skilled, dedicated, working 12-hour shifts 6 days a week. The problem is that building one perfect Tu-4 prototype is entirely different from building 100 production Tu-4 South. The prototype was assembled by hand-selected engineers who could spend 3 days perfecting a single bracket. Production aircraft need to roll off the line every week, built by workers who've never seen an American B-29, following blueprints that are still being revised. And the blueprints are the first nightmare. When Tupolev's team reverse-engineered the 3 B-29s, it created documentations of technical drawings, material specifications, assembly procedures. But American engineering drawings used different conventions than Soviet ones. Different projection methods, different dimensioning standards, different tolerances. The conversion process created errors. Small ones, mostly. A dimension transposed. A tolerance misinterpreted. An assembly sequence that seemed logical on paper but proved impossible on the factory floor. Each error multiplies across the production line. A bracket that doesn't quite fit. A panel that's 3 millimeters too wide. Bolt holes that don't align. Workers improvise, file things down, force components together that should slip into place smoothly. And each improvisation means the aircraft isn't exactly like the prototype, isn't exactly like the American original, becomes something slightly different, slightly less perfect with each deviation. Sokolov has reported the problems up the chain. It's begged for engineering support, for revised drawings, for someone from Tupolev's bureau to come to Kuybyshev and help them solve these issues. But Tupolev's team is spread thin across multiple production facilities, putting out fires, and Kuybyshev isn't the only factory struggling. At factory number 22 in Moscow, the original facility where the Tu-4 was developed, production is moving faster. They have the prototypes on site, can reference the American originals when questions arise. But even there, quality issues plague every aircraft. The pressurization seals leak. The electrical systems develop intermittent faults. Engines fail. Acceptance testing at alarming rates. Each problem requires investigation, correction, documentation processes that slow production to a crawl. Stalin wants 15 aircraft per month by the end of 1947. The factories are producing 4, be 5 if they cut corners that shouldn't be cut. And the pressure is immense. In December 1947, Tupolev is summoned to the Kremlin. He arrives expecting praise for the successful test flights, for the growing fleet of Tu-4 south entering service. Instead, he finds Stalin standing over a production report, his face carved from Georgian stone. For aircraft last month, Stalin says without preamble, I was promised 15. The production issues are being resolved. Comrade General Secretary, we're implementing. I don't want explanations. Stalin's voice is quiet. Dangerous. I want bombers. The Americans have hundreds of B-29s. Hundreds, we have fewer than 22 for South. This is unacceptable. Tupolev knows better than to argue. You will increase production. You will triple it. By March, triple production in 3 months. It's impossible. But impossible isn't a word you use with Stalin as Comrade General Secretary. What follows is a production campaign that turns Soviet aviation factories into industrial war zones. Work shifts extend to 14 hours, then 16. Weekend leave is canceled. Workers sleep in factory dormitories, eat in factory cafeterias, live and breathe aircraft production. New quality control protocols are implemented. Inspectors at every stage of assembly catch defects early rather than discovering them during final testing. It slows production initially, but reduces waste, reduces rework, gradually builds momentum. The engine problem is tackled through brute force. If 1 in 3, a 7.3 TK engines fails acceptance testing, the solution is to build more engines. Factory number 19 in Perm is retooled specifically for engine production. Workers are transferred from other facilities. Machining equipment is duplicated, tripled. The factory becomes a single-purpose organism dedicated to producing Wright R-3350 copies. By February 1948, engine production has doubled. By April, it's tripled. The failure rate drops as workers gain experience, as manufacturing processes are refined, as the accumulated lessons from thousands of test runs are incorporated into production procedures. But the human cost is staggering. In Kuybyshev, Pavel Sokolov collapses on the factory floor one afternoon, unconscious from exhaustion. He's taken to the medical station, given glucose injections and hot tea, then sent back to work 4 hours later because there's no one to replace him. In Moscow, Svetlana Petrova, the electrical systems expert who mapped every wire in the original B-29 works 72 hours straight, troubleshooting a recurring short circuit in the radio system. When she finally solves it, she walks to her tiny apartment, lies down on her bed, and sleeps for 19 hours. Marriages crumble under the pressure. One engineer, driven mad by stress and sleep deprivation, attempts to sabotage a partially assembled fuselage. He's caught immediately, arrested, and disappears into the Gulag system. The incident sends shockwaves through every factory, a reminder that Stalin's patience has limits, and those limits are measured in years of hard labor. Yet somehow impossibly production accelerates. The breakthrough comes from an unexpected source: the workers themselves. Engineers can design perfect systems, but workers who assemble components day after day develop an intuitive understanding of what works and what doesn't. They begin suggesting modifications, small changes to assembly sequences, jigs that hold components more securely, techniques that speed up repetitive tasks. A welder in Kazan discovers that preheating aluminum panels reduces warping during installation. A riveter in Moscow develops a rhythm for driving fasteners that's faster and more consistent than the documented procedure. A painter in Kuybyshev formulates a lacquer mixture that dries 20 minutes faster, without compromising durability. These innovations spread through informal networks, workers talking during meal breaks, visiting colleagues at other factories, sharing techniques that the official engineering documentation never captured. It's folk knowledge, industrial wisdom passed person to person, and it makes the difference between quotas met and quotas missed. By June 1948, production hits 12 aircraft per month. Not the 15 Stalin demanded, but close. Close enough that the NKVD officers who haunt factory corridors seem slightly less menacing. Close enough that workers dare to hope they might survive this. The first operational Tu-4 regiment forms in August 1948 T-18 bombers. Complete crews based at an airfield outside Kazan. The unit designation is 230th Guards Heavy Bomber Aviation Regiment, a title heavy with prestige and expectation.
Oh.
These are the men who will carry Soviet air power across continents if war comes. Their commander, Colonel Vladimir Reshetnikov, is a veteran of the Great Patriotic War, flew bombers against the Germans, survived missions that killed most of his squadron. He's tough, competent, and deeply skeptical that this copied American bomber is ready for operational service. His skepticism proves justified during the first long-range training flight. 3 bombers take off at dawn, destination, a bombing range 800 kilometers distant. They're supposed to demonstrate that the Tu-4 can execute the missions it was designed for, reach distant targets, deliver ordnance accurately, return safely. The first bomber develops hydraulic problems 200 kilometers out. The bomb bay doors won't open. The pilot aborts, limps back to base trailing fluid from a ruptured line. The second bomber makes it to the target, drops its practice bombs, then loses an engine on the return flight. The crew feathers the propeller, maintains altitude on 3 engines, but the bomber is struggling. They make an emergency landing at an alternate airfield, touching down with fuel gauges reading nearly empty. Only the third bomber completes the mission without issues.
1 out of 3?
Reshetnikov files a scathing report. The Tu-4 isn't ready. The reliability problems need to be solved. More training is required for both crews and maintenance personnel. Throwing these bombers into operational service prematurely would be catastrophic. The report reaches Tupolev's desk 3 days later. He reads it in silence, his expression unreadable. Then he picks up the telephone and begins making calls to factories, to engineering bureaus, to military testing centers. Within a week, teams are dispatched to Reshetnikov's regiment to investigate every system, every component, every potential failure point. What they find is sobering. The operational aircraft have problems the prototypes never showed. Vibrations from prolonged flight are causing fatigue cracks. The remote gun turrets, reliable in short test flights, develop tracking errors after extended operation. Hydraulic seals that worked perfectly in laboratory testing fail under the temperature cycling of repeated missions. These aren't design flaws. They're the inevitable gaps between theoretical perfection and operational reality. Every aircraft goes through this phase, the transition from controlled testing to brutal service conditions. But the Tu-4, born from reverse engineering rather than original design, is particularly vulnerable. The Soviets copied what they could see, but couldn't replicate the decades of American engineering experience that shaped every decision. So they learn, rapidly, painfully. Hydraulic systems are revised. Seals are upgraded. Inspection intervals are established for components prone to fatigue. Maintenance procedures are written, rewritten, refined based on feedback from crews who actually fly these bombers in all weather, at all altitudes, under operational stress. By the end of 1948, the Tu-4 is becoming a mature aircraft. Not perfect, it will never match the reliability of its American progenitor, but functional, capable, ready to fulfill the mission Stalin demanded. And the production numbers keep climbing. 15 aircraft per month by December. 20 by March 1949. Factories across the Soviet Union humming with the machinery of strategic air power. But there's another dimension to this story. Another layer of pressure that drives everything forward with desperate urgency. Because on August 29, 1949, the Soviet Union detonates its first atomic bomb, a plutonium implosion device named First Lightning. The test is successful. The yield is 22 kilotons, enough to obliterate a city. And suddenly, the Tu-4 isn't just a copied American bomber. It's a delivery vehicle for nuclear weapons. The only Soviet aircraft capable of carrying an atomic bomb to distant targets. The cornerstone of Soviet strategic deterrence in an emerging Cold War. Stalin's insistence on exact copying, on rushing production, on accepting nothing less than hundreds of bombers at all, makes terrible, perfect sense now. He knew, or guessed, or simply understood that in the coming confrontation with the West, strategic bombers and atomic weapons would define survival itself. The Tu-4 fleet expands rapidly after First Lightning. New regiments form, training intensifies. Bombers practice long-range navigation, high-altitude bombing, penetration of air defenses. The Soviet Air Force is learning how to wage atomic war. And through it all, the factories keep building, keep improving, keep pushing past exhaustion toward quotas that never seem quite achievable, but somehow, month after month, get achieved anyway. Pavel Sokolov, still foreman at factory number 18 in Kubyshev, watches the 100th Tu-4 roll off his production line in October 1949. It's a moment of quiet pride. It's mixed with bone-deep fatigue. 100 bombers. 100 times they've assembled 47,000 components into something that flies, that works, that could carry destruction across continents. He doesn't go home that night, just stands on the factory floor, watching the next fuselage section being positioned, the next aircraft beginning its journey from raw materials to strategic weapon. Because the quota for next month is 25 aircraft. 25 aircraft means another month of 16-hour days, pressure and stress, and the constant awareness that failure could mean a visit from men in black cars. But also another month of building something that didn't exist 2 years ago. Another month of industrial achievement that rivals anything in Soviet history. Another month of proving that Stalin's impossible demand, copy the B-29 exactly, was less impossible than anyone imagined.